Mona mentioned about AI earlier. So she mentioned ChatGPT. Copilot, I put some words into what my job did. It came up with this rather snappy title of transforming efficiency through innovation. So I'm sure AI can do a little bit more on that, but small steps. So we talk about the alliances and what we do. So just for example, this is my efficiency programme for the last control period. And we had a target to save £25 million beyond the target. So we agree a target with the routes and regions, and we also then strive to deliver efficiencies beyond that target. And we actually have a contracted efficiency of 3.8%. So over the last control period, we actually saved £35 million beyond the target. So, and how did we do that? Well, it's not just me. I'm pretty useless. So we set a target for each of our regions. So I saw Alan's in here. And it's all through, mainly, continuous improvement. Everybody's encouraged to make that little bit different. You know, can they do your job that little bit better? We share with pride, we copy with pride, we steal with pride. We have an active supply base, we have a suppliers forum. They're all invited to the party. Where possible, although we've got an active supply base, we try and do as much ourselves with our PSM staff. Network Rail are paying for those PSM staff. We need to maximise and use them as much as possible. So in-house surveys are a massive big stride we made. And someone just sent me an efficiency, just in Wales and Western, we reckon we saved 300k this year just by doing the survey ourselves, which is huge. And then also there's some bigger projects which falls into my team to manage. So I'm going to talk about a few of those things. And you'll notice a meet's all digital. I'm a little bit more analogue, but there's nothing wrong with having a bit of both. So sustainability. So there's an awful lot in this conference about sustainability. And this slide was shown to me where, well, how much embedded carbon is in a track renewal. So probably no great surprise that over 60% is actually the rail. Loads of embedded carbon in rail. I think Darren Sharp was telling me, I think there's 2 tonnes per metre. Is that right, Darren? Or somewhere along that. It's a lot anyway. But technology like electric arc furnace and stuff like that will help us deal with that. The next biggest slice, though, is the pink section, and that's the sleepers. Over 30% of our embedded carbon in the track is as a result of our sleepers. So we've done some great strides. So concrete's gone down from about 80 kilograms to about 40, 50. So massive, that was already mentioned this morning. We got the cycle composite sleepers, again, compared to a wooden sleeper, massively reduced. But the only problem with the composite sleeper, well, I say problem, is they use base plates rather than integrated housings, and they don't particularly lend themselves to track renewal. So I sort of rather stupidly said, well, can't have a composite sleeper with a fast slip housing. And the answer I actually got was no, which was a bit bizarre. So, of course, anyone says no to me, if they know me well, that's sort of like just a red rag to the pull, and I thought I can do better. So I set about trying to get some money to make an integrated composite sleeper. So a composite sleeper, so using recycled plastic, recycled car tyres, and basically have an integrated housing in it. And, oh, here we are. We have the hedgehog sleeper, which is a little bit of a strange design. It's called the hedgehog sleeper because the Dutch company said it looks like a hedgehog. I think it looks a bit more like a crocodile, but I'm not going to really split hairs on it. But we managed to reduce the embedded carbon quite significantly. So about 90% less embedded carbon compared to a hardwood sleeper. And 79, this is probably a little bit less now than the good work Darren's done with the concrete manufacturers, but a lot less. At the moment in time, it's made from about 90% recycled materials. However, going forward, the electric arc furnace, because there is steel in this, that'll come down to 100% recycled materials. And at the end of its life, the whole thing can be ground up and made into another sleeper or whatever it is. It exceeds the performance of concrete in just about every parameter, and I'll show you a little bit about all that. And what's really, really pleasing, I set out to have an EG47 equivalent, a G44 equivalent. I now have a single design which basically performs the same as a shallow depth, full depth sleeper, but also does third and fourth rail at exactly the same time. So one product does the job of every single other sleeper. So there's just a little bit more information. We'll share these slides, and I'm just a bit conscious of time, so I won't go into it. But the sleeper's designed to work with all our existing plants, such as the TRS, should we choose to keep it, ballast cleaners, and there's other factors. So lateral resistance, although it only weighs 78 kilograms compared to 308 kilograms for the G44, we actually have greater lateral resistance. and that's due to do the design of the sleeper. So again, what do we make the hedgehog sleeper out of? Well, believe it or not, it's beer crates and bottle tops. So beer crates are very close to my heart, so I'm happy I can do something to make that better. It's injection moulded, high density polyurethane, and the beauty is at the end of its life, should we ever see the end of its life, because it's plastic, we can just grind it all up again and make more sleepers. So we talk about the circular economy. This is exactly the circular economy. Lateral resistance, so have to put our money where our mouth is when we make these sort of claims. So the red line is the G44 sleeper doing lateral resistance tests. The orange line at the top is the hedgehog sleeper. So it's actually been proven in the lab that it has greater lateral resistance. So we talk about climate change, being able to resist that hotter weather. The hedgehog sleeper does that for us, or helps us. This is and I'll put a cover all. This is G44 without a under sleeper pads before Darren corrects me on that one. Again, we've got these wings on it, and actually, believe it or not, we did some testings with 1 wing, no wings, 3 wings, the whole lot goes on. And actually, the wings weren't making any difference at all to lateral resistance. But we have a phenomenon most track engineers know called ballast drift. By putting these wings in, it stops the ballast drift. So actually, it keeps the ballast where it needs to be. And of course, it wasn't really much extra plastic to have the wings in there, so we left some wings in. Actually, then we sort of talk about shape, width, and length, and all this sort of stuff. We did lots and lots of testing to try and find out what the shape of the sleeper should be. And we came up with an optimum design. So it's the same length as an EG47, so it goes with the track relaying system. It's the same height as an EG47, so we get all the benefits of a shallow depth sleeper, extra clearances and all that sort of stuff. But because we lost the height, we have to make it a little bit wider. So it's actually a 350mm wide sleeper, which is the same as a G55 cable management sleeper. But as a result of that, basically the top bit is the deflection you get a rail seat. So the top graph, I don't know if we've got a laser pointer? Yeah. That one there is what a G44 is. And that one there is what our hedgehog sleeper made out of plastic is. So very, very similar properties. But actually the centre bending moment, because concrete sleepers are so stiff, actually when the sleeper goes down, the whole sleeper sort of deflects and bends, well, is very stiff, so they don't do the loading very well. But because the hedgehog sleeper is made of plastic, we get far less centre bending moments. So we actually got a far better balanced sleeper. So in theory, actually, the forces are transmitted into the subgrade far better, and we should have a longer lasting subgrade as a result of using a G44, a integrated composite sleeper. And again, we're testing these as well, these sleepers, to match the equivalent of a concrete, so we should be able to use them in Cat 1A track, but we're undergoing all the static and dynamic testing as we speak. So sort of about an engineering product. Someone mentioned 3D scanning earlier. Well, we use 3D scanning to check that every sleeper that comes out of the moulds to its geographic tolerances. This is one of our early tests. The green is actually spot on to the CAD model. The blue, although it would pass all our tests, what we say is a good flat sleeper, actually, the company we're working with actually, because the mould, the plastic goes in hot and it shrinks in the mould is bigger than the finished product. So we're just doing some work to refine the mould, so actually those blue bits become green. So that's the level of detail we're going to. And every sleeper that comes off, quickly scan it on the combustion line, perfect sleeper every single time. Obviously looking where the read bars are for reinforcement using x-rays, and here's some of the static testing. One of the big questions I get me is how much do these sleepers cost? Composites are very, very expensive. And I'm a little bit fed with answering the question, but I'll answer the question. So a side cut, by the time you put base plates on, sorry, I won't use the word side cut, a traditional composite, by the time you put all the base plates and everything on, somewhere around 200 and 250 quid, depending on the base plates. That's because there's a lot of manufacturing to actually just drill those base plates down, and steel's expensive. Because we've got an integrated fastening, actually, when we start talking economy of scale, we're down to about £154 per sleeper. More expensive than a concrete, granted, but an awful lot cheaper than a base-plated composite. And when you're talking about its whole of life costs, again, I don't know how long one of these will last, but it's going to last quite a while in the infrastructure. From a whole life cost perspective, these will really bring the cost down. And then just talking about the circular economy, local jobs. That there is about the size of a tennis court. That's the plant, the injection moulding plant, to produce an integrated composite sleeper. Once we get to about an order about £50,000, 50,000, 60,000, Langhorse, who makes these in Holland, it's then economical viable to actually go and build these in the UK. Wales and Western, we put 80,000 concrete sleepers in last year. We only need about 50, 60,000 to make this project viable. In Wales and Western or the other region, we could have this at a local railhead making sleepers actually at the railhead, local jobs for local people, no carbon, no transportation of the sleepers, straight into the train, straight to the job. There's absolutely huge benefits to this, rather than massive, big, huge concrete sleeper factories. So there we are, and this is the inner trans, and for our European colleagues, we've got some nice Foslo fastenings as well, should we need them. How am I doing for time? 5 minutes. Okay, I'll quickly back through. So, although we talked about digitisation, we do digitisation on the Southern Alliance. And just quickly, one of the things we've got is Safe Work Pack 019 compliance. The on-track system was written really for our colleagues in maintenance, and we struggled in track renewals to make that system work. So we now launched a new system called AccuRail, which basically takes all the sort of peculiarities of track renewals, and now we have a fully digital safe system work pack, which is basically, we launched it in July, and now right across the Alliance, our supply partners, everything, we are fully electronic safe work pack, so that's really pleasing. That's AccuRail, and we're now moving to a system called Sensite, to basically all our Form A's, G's, all our engineering forms, assurance checks, everything like that will all be digitised going forward. Life-saving rule, never enter an agreed exclusion zone unless directed. We all know we're absolutely awful at managing our exclusion zones. So we're working with a company called Zonar, and fundamentally this is a dynamic exclusion zone, so as the boom goes out, the exclusion zone enlarges, as the boom goes in it's smaller, but also when someone steps in the exclusion zone within 10 metres, the person gets an alert on his tag, and the machine controller gets an alert on their tag, so the machine controller can take charge of his exclusion zone. If a person then gets within 5 metres of the excavator, bear in mind we walk about a metre a second, the operator then gets the user gets a constant alert, the machine controller gets a constant alert, and also the operator in the cab gets an alert, basically saying, stop, there's somebody in harm's way, stop doing it. So we're trialling this at the moment. System review panel again for this, similar to with speed boards, but we'll be rolling this out hopefully very soon right across the Alliance. And then we talked about getting the right plant. This is something we designed, which is a heavy duty rail crane. Basically it's an RRV version, but it has the same lifting duties as a Kirov 250, and it'll be about 40% cheaper to operate. Trouble is I've got a design, fully functioning design, I need someone to pay for it. When I talk to my supply base, well, give me a workbank, Nick, and we'll go and buy some, but we're not very good at underwriting workbanks. In fact, we're awful at it, and it's something we need to do. And then finally, green sites, so we're trying to put solar panels on our welfare roofs. But this is another little thing I've got some small amount of R&D funding for. Sun doesn't always shine, especially in Wales, as Brian will allude to, but we always have lots and lots of wind, so let's harness some wind power, charge a battery storage unit, and power our welfare there. So thank you, and I'm trying to see who I'm handing over to. There we go. So thank you.